Okay, welcome from the 403 to the HAZ, Mr. Nelson in the house. Here to teach you a fundamental skill that we need to be successful in life. That is, no, not to be successful in life. You can be successful in life without knowing how to add and subtract fractions. It'll just make it easier, okay? I don't want to be all dramatic and overly self-important about what I'm teaching here, but math is important. Knowing how to add and subtract fractions will make life easier at times. And it will allow you to do some more technical things in life. So, adding and subtracting fractions. Well, why do we need to know how to add and subtract fractions? Because not at all are we ever going to be given things in the same quantity. So for example, say I have a half, or let's say I have a quarter of a pie, and somebody gives me a third of a pie. And I want to know, well, how many slices of a pie does this actually work out to be? Well, in this case, I cannot add these pieces of pies together just saying like 1 plus 1. Oh, it's 2. It's not 2. Okay, so 1 out of 4, and I'm adding a third. What I need to do in order to be able to add these is find a common pie that's split into pieces so that I can actually have split up pieces of this amount that's equivalent to this. And I call that finding the lowest common denominator. And the secret for finding the lowest common denominator, is to just multiply the denominators together. The denominator is the number on the bottom of the fraction. Okay, this is the denominator. And this is, the number on the top is called our numerator. Okay? But to determine a lowest common denominator, the easiest thing to do is to multiply those two numbers together. So I get 12. So I am going to split both of these pies into 12 equal slices. Okay, and I can do it by splitting each of these slices into 4. Okay, equal slices. They're all going to be even slices, even though they don't look like it on my drawing. Okay? And when I do that, when I split this pie up into 4, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the slices that I have account to 4 slices. So on this pie, I'm going to have 4 out of 12. And on this pie, if I slice it into 12, all I have to do is cut each piece into 3 equal slices. And I am going to get 12 here. And the slices I have are 1, 2, 3. So that's going to be 3 out of 12 on this side. And once I have 2 pies that have the same amount of total slices on the denominator, 12 and 12, well then I can add them together. And I can add them together just by adding the slices I have. I have 1, 2, 3, 4, 5, 6, 7, or 3 plus 4, out of a 12 sliced pie. And then this adds up, 3 plus 4 is 7 out of 12. That is just a quick crash course on what we're doing and why we do it this way. But let's talk, before we jump into adding and subtracting in more detail, let's just talk about something we call equivalent fractions, okay? Equivalent fractions. Equivalent fractions are fractions that may not have the same denominator or numerator, but they represent an equal amount. So I could have a half a pie, and I could also have 2/4 of a pie, and I'm going to have the same amount of pie if I were to eat assuming that both these pies are the same size around, okay? 1/2 is the same as 2/4. What else is the same as 1/2 or 2/4? Well, I could take that pie and I could split each of those slices in half. And if I had all of this, well, now that's 4 slices out of 8. 4 out of 8, 2 out of 4, 1/2. Okay? These are all equivalent fractions. They all represent the same thing. Some other examples of equivalent fractions are 1/3 is the same as 3 out of 9, which is the same as 9 out of 27. Okay? We need to be able to understand how to convert between different fractions with equal equivalency, because that's going to be a skill that we use when we set up our fractions, when we're adding and subtracting, when we're finding the same denominator. We have to know what to do to the numerator. So, let's say I have 5 out of 15, and I want to know what that fraction is out of 60. Okay? So I've taken a pie that's split into 15 slices where I have 5 slices, 5 out of 15 slices, but now I'm going to turn that pie, I'm going to cut it into 60 slices, and I want to know how many slices I'll have to have out of 60. So you can imagine the slices are going to get a lot smaller. How many slices out of 60 do I need to have to eat the equivalent, the same weight as 5 out of a smaller sliced pizza or pie or whatever? So to do that, I recognize that, okay, well, what did I have to do to 15 to get it to 60? And you could try doing 60 divided by 15 or whatever, and I'll find that I have to multiply 15 by 4 to get to 60. So if I have to multiply the amount of slices by 4 to get 60, well then I'm going to have to do the same thing to the amount of slices that I have. So if I'm multiplying the denominator by 4, I'm going to have to multiply the numerator by 4, and I get, so 20 slices out of these smaller slices is equivalent to 5 slices out of 15 there. Okay, so what if I had 20 25ths, and I wanted to know what the equivalent is if I were to actually have much bigger slices but only 5 of them? Well, in this case, instead of multiplying, I am dividing. 25, to get to 5, I have to divide by 5. Therefore, if I'm dividing the denominator by 5, I have to divide the numerator by 5. 20 divided by 5 is 4/5. So 20 25ths is the same fraction as 4/5. A couple more here. Let's say I have 2 7ths, and I want to know what that is out of 21 when I split this into much smaller slices. Well, 7 into 21 requires a multiplication of 3. Therefore, I'm going to multiply. If I have 7 slices total, and I multiply those slices, or split those slices up into 3 each to get 21, I'm going to have to do the same thing, and each of my slices I'm going to split into 3, which means that I get 6 in all. 6 out of 21 is the same as 2 out of 27. 2 out of 7, sorry. And so we're either going to be dividing or multiplying our numerator in both cases. And whatever we do to the numerator, or to the denominator, we do to the numerator. So I could also say, say I have 5 6s, and I want to know how many slices does my pie have to have if 10 slices is the equivalent as having 5 out of the previous thing. Well, now I'm just looking at the numerator first, and I multiply the numerator by 2 to get to 10. So to have an equivalent, the same equivalent means I'm doing the same thing to the bottom and the top. I'm going to have to do this. That's equivalent fractions, and this is what we're going to do when we start figuring out our lowest common denominator when we're adding and subtracting. So, what does this look like in practice? We'll say I have 2/5 and I add 2/3. Okay, these pies have different numbers of slices, so I cannot just go ahead and add them. I have to turn them into equivalent pies with equivalent slices so that I am comparing apple pies to apple pies. Okay, so what do these two have in common? What's their lowest common denominator? Well, I can easily find that by just multiplying them together. So 5 and 3 makes 15. So I am going to make both of these fractions out of 15. Okay, so what did 5 have to be, what did this denominator have to be multiplied to get to 15? 3. So whatever I do to the bottom, I'm going to do to the top here. And actually I'm going to show this in a much, like I just had it. This doesn't make sense. So they have to be fractions out of 15. So let's do 2/5 first. 2/5, and I want it to be a fraction out of 15. So 5 times 3, well, they make that, therefore 2 times 3 over here. Whoops, 2 times 3 is 6. And 2/3, so this becomes, this becomes 6/15, and then 2/3 to be a fraction out of 15 means that 3 is multiplying by 5 to get to 15, therefore 2 is multiplied by 5 to get 10. Now I have 2/5 is the same as 6/15, and I'm adding 10/15. 2/3, which is the same as 10/15. They keep the same denominator, and now I'm just adding the slices. 10 plus 6 is 16 out of 15. And 16 out of 15 means I have a whole with 1 out of 15 left over. So this is the same, that's the answer there. That is adding. And we do the same thing with subtraction, except we just subtract at the end. Okay, so let's say I have 6/7, and I subtract 2/3. Okay? So I have different denominators. I need a common denominator. So I'm going to actually multiply these two together to figure out a decent denominator. This may not be the lowest common denominator always. A good example is if I had 2 out of 8 and 1/6. If I multiply these together, it gives me a common denominator of 48. However, the lowest common denominator between an 8 and a 6 is actually 24. But I can just divide by 2 at the end to get the same result. It's going to work out either way. I can just simplify that fraction. So I get 21. So 6 out of 7 we have to turn into a fraction out of 21. 7 times 3 makes 21, therefore 6 times 3 is 18. That's my first fraction. 2/3 is equal to a fraction out of 21. 3 times 7 makes 21, therefore 2 times 7 makes 14 out of 21. Now I have 18 out of 21, which is the same as 6/7, minus 14 out of 21, which gives me 18 minus 14. 18 minus 14 out of 21. I keep the denominator. 18 minus 14 is 4 out of 21, and that is my answer. Okay, that is adding and subtracting fractions, a quick crash course just to kind of get you remembering what to do here. Okay, thank you very much.